My name is Mike Watts and I'm an engineer here at NI. Today, I'm going to show you how to use the semiconductor power and performance validation solution to quickly and interactively perform power measurements. As the demand for power efficiency grows and low power devices are becoming more and more common, it's becoming increasingly difficult and increasingly important to gather power consumption data to fully understand how a device performs, not only the job it was designed to do, but also the amount of power that it consumes while doing that job. This solution is a high channel count, high accuracy solution that's commercially available and was designed for these types of power measurements. And it can help you accelerate time to market and help secure design wins with your end customer. This solution is built around the PXIe 4309, which is a flexible resolution analog input module. It's an instrument that was designed for this exact use case, low-level shunt resistor-based power measurements. It uses advanced DMM-like features for signal averaging, filtering, and auto-zeroing to deliver up to 28 bits of resolution for repeatable nanovolt level measurements. Or if speed is your primary concern, it can also sample at up to 2 megasamples per second per channel. For connectivity, you can connect bare wires to the optional screw terminal block, or you can cable directly to an evaluation PCB or load board for the best signal integrity and ease of use. Today, I'm demonstrating our 2-slot PXIe 1090 chassis to showcase an ultra-portable version of this system. But there are also options that range up to 18 slots, so you can fit hundreds of these measurement channels into your system, and you can customize it to fit your needs. Let's jump to the software portion of the system. The power and performance validation solution uses NI Flex Logger to configure, measure, and analyze power consumption data, all without programming. Within Flex Logger, there are multiple tabs that allow us to configure the instrument channels, data logging information, test specifications, and then visualize the acquired data. Let's start in the Channel Specifications tab, where Flex Logger has already identified the PXI setup and the PXIe 4309 instrument. For this demonstration, I'm going to measure the power consumption of one power rail, which actually requires 2 measurements, a voltage measurement and a current measurement, and I'll use 2 separate measurement channels to perform those measurements. Let's set up the first one by renaming the channel, selecting the measurement type, remove any offset that may exist, and then configure the input parameters, knowing that this is a 3.3 volt rail. For my second channel, I'm going to measure the current that flows through a sense resistor. So I'll select a current measurement and the sense resistor as the sensor, remove the offset, and then select the lowest measurement range possible, knowing that the value will be in the nanovolt range. Flex Logger also handles the synchronization capabilities all behind the scenes, so we know that our measurements are synchronized without any extra work for the user. Rather than duplicating this process for each additional power rail, you can simply copy and paste as many copies as you'd like. For today, I'm going to just stick with one power rail. Now, I can also create formula-based calculated channels that use standard math operators. For example, I'm going to create a power calculation that multiplies the raw voltage measurement and the raw current measurement, and then returns a single instantaneous power value for this pin. This calculated channel can now be used as if it was its own physical measurement channel, meaning that I can display this data for the user and log the data to disk. Speaking of logging, let's move on to the Logging Specifications tab. Here, you can configure the file details for logging the data to disk. By default, Flex Logger uses a TDMS file format, which is an NI binary file format that includes all of the raw measurement data, as well as relevant metadata like channel configuration, user information, and DUT type. TDMS files can be opened in a spreadsheet viewer like Microsoft Excel, or you can choose to log to a CSV file format if you prefer. Rather than logging the measurement data nonstop, you can also choose to configure start and stop triggers when the measurement level exceeds or drops below a certain value, as an example. For now, I'm going to leave the logging start and stop triggers blank, meaning that we'll log the data to file anytime we run the program, and then it will stop logging when we press stop. There's also a test specifications tab where you can configure event-based actions. For example, if a signal were to pass a certain threshold, you can create an event that will trigger a safe shutdown procedure or turn the device off. I'm going to skip this step for now as our demonstration is pretty basic. Finally, we will configure the data screen, which is where you visualize the data. In my example, I'm going to simply plot the current data on a graph. I'll configure the y-axis for the range. Now let's see it in action. After pressing start, you'll notice that FlexLogger is now logging the data to file. I will go ahead and toggle my part in and out of its sleep state, which will generate about 10 microamps of current while in the sleep state, and then roughly 0 amps when it's powered off. While FlexLogger is logging the data to file, you can also add user comments that will be time-stamped and added to the metadata, which is really helpful for marking some unexpected behavior that you want to follow up on. You can also pause the data screen independently from the data logging operation, so you can zoom in or take a screenshot and then resume with the live data when you're done. After the tests are complete, you can view and open the TDMS data file in the convenient and powerful built-in data viewer. Here you can see the test information, you can zoom into the data, and you can even replay the data in real time. When you're all done, make sure you save the project so that you can share it with a colleague or come back later and pick up right where you left off. And that is how you can use the NI semiconductor power and performance validation solution to quickly configure, measure, and analyze power consumption data. For more information on NI semiconductor test solutions, visit ni.com/semiconductor.